Now aim concept. So in the modulation process, the voice, video or digital signal modifies another signal called the carrier. Means we are going to modify the carrier signal with respect to the frequency, with respect to the phase, with respect to the amplitude, with the information signal. Means that can be the voice, that can be the video or digital signal. It is not necessary it should be analog. So in amplitude modulation, the information signal varies the amplitude of the carrier sine wave. Now the instantaneous value of the carrier amplitude changes in accordance with the amplitude frequency, same thing. An imaginary line envelope connects the positive and negative peaks of the carrier waveform. So it can be look like, now this signal can be called as a modulating signal, information signal. So because it is still modulating signal, it is going to be modulated. So this is the basic signal. You can call it information, message, user data, baseband signal. Now this is the aim concept. Now this signal will be modulated signal or unmodulated. So the figure is in front of you, the figure B. This signal, you can call it a modulated signal or unmodulated signal. Okay. This is the modulated signal. Here the amplitude is modulated. It can be clearly visible and we can get such a result with the programming. Now aim concept, it is particularly important that the peak value of the modulating signal be less than the peak value of the carrier signal. So very important point. One is the modulating signal and other is a carrier signal. And you have to keep in mind when you are going to develop a program for amplitude modulation, peak value of the modulating signal should be less than the peak value of the carrier signal. Distortion occurs. Your signal is going to be distorted when the amplitude of the modulating signal is greater than the amplitude of the carrier signal. So what will be the three conditions? Anyone who know cover from the theory? There are the three cases. One case is modulating signal value can be equal to the carrier. Modulating signal value can be less than the carrier signal. Amplitude of the modulating signal can be greater than the carrier signal. So anyone can compare all three. Whenever we are going to perform the modulation, we have the different modulators and demodulator circuit. So a modulator is a circuit used to produce the amplitude modulation. So whenever physically you will come in lab, inshallah, whenever we are going to perform the amplitude modulation, we will have the modulator circuit that actually modulate a signal in amplitude. So there are certain modulator circuit and that are going to modulate our signal. So if we are talking about aim modulation, so there will be the modulation circuit, modulator circuit for modulating in the amplitude domain. Then amplitude modulators compute the product of the carrier and modulating signal that is in front of you. So I think mathematically you have also covered it in your theory. Again, I am repeating it for you. This is the incoming signal. That can be the modulating signal, means unmodulated signal, information signal. Here it is going to be modulated with the help of carrier signal. At the end we get this signal, Vc sine 2 pi fct and Vm sine 2 pi fmt sine 2 pi c. So let us means prove this equation, means output equation. So this is the amplitude modulation equation. So one is the carrier signal that can be represented as a V of C, means carrier signal magnitude or amplitude, WC representing the angular frequency, and FC is the carrier frequency. Other is a modulating signal. So amplitude modulated wave can be represented as a combination of the both, combination of the carrier and combination of the modulating signal. So we have just substitute and take the common cos omega ct. Then actually for simplifying purpose, if you will take the common Vc, so this will be again here 1 will comes and here Vc will be divided. This is actually the ratio of the amplitude of the modulating signal over the amplitude of the carrier signal. That will be called as a. So actually this is the modulation index. MA modulation index, that is very important. Where notation M is termed as the modulation index, it is simply the measurement of the degree of the modulation and bear the relationship of the amplitude of the modulating signal to the carrier signal. So I am coming and returning to my point where I left you. This is modulation index. So equation से मैंने आपको ये चीज बताई कि ये कहां से आ रही है. Now we can discuss it. A modulation index is the value that describes the relationship between the amplitude of the modulating signal and the amplitude of the carrier signal. So now it is clear to all of you. The index is known as modulating factor or the modulating coefficient or the degree of the modulation or the modulation index. So you should not be confused with these terminology. Some books and some internet sites are calling it modulation index. Some are calling it modulating factor. Some are calling it modulating coefficient, or some are saying this is the degree of modulation. So multiplying the modulation index by 100 gives the percentage of the modulation. So here modulation index and percentage of modulation means over modulation and distortion. So the modulation index should be a number between 0 and 1. So if the amplitude of the modulating voltage is higher than the carrier voltage, the M will be greater than 1 and causing distortion. If the distortion is great enough, the intelligent signal becomes unintelligible. Then the second is distortion of the voice transmission produces harsh, unnatural sounds, means your quality of the voice signal can be compromised, and distortion of the video signal produces a scrambled and inaccurate picture. There will be the low pixel video on the screen. So over modulation is not a desired modulation, degree of the modulation, it always produce distortion. In terms of the voice, there will be the unnatural sound, unwanted frequency, harshness, garbled, a noise type sound. In terms of the video signal, there will be the some pixels, low quality, inaccurate picture on the TV screen. So this is in front of you. Distortion of the envelope caused by the overmodulation where the modulating signal Vm is greater than the carrier signal. So we are going to prove it.